Sometimes we are interested in finding the area of plane figures or measuring the length of plane figures. Also, we might be interested in finding the volume of solid shapes. Mensuration has to do with finding area and length of plane figures or volume of solid shapes. For instance, the trapezoid has its perimeter as the distance around it, that is A plus B plus C plus D. Then the area is given by half the sum of the power size times the vertical height. For the rectangle, the perimeter is 2 times the length plus the width, or A plus B times 2. Then the area is the length times the width, or A times B. Then for the square, we have 4 times the length. Then the area is length squared. The perimeter of the parallelogram is given by this 2 times A plus B, just like the perimeter of the rectangle. Then the area is given by the base, which is B units times the height. Don't forget that this is also B units. Now for the kite, the perimeter is found by this. You know, this one has this side equal this also equal this. So the perimeter is also given by this 2 times the sum of this side plus this. Then for the area, we can find the area of the triangles and sum them up. The same thing applies to the rhombus. So the perimeter is the distance around, then the area is finding the triangle, area of the triangle, any one of them, then multiply by 2. So let's say area is triangle ABD by 2. So you know the diagonals. So if you take this diagonal, half of it will be this, then this will become your vertical height. So find the area of this, multiply by 2 to get the area of the rhombus. Then we have arc and sectors. This is a minor arc and this is a major arc. Now the formula for finding the length of the arc is the same for all, whether it is minor arc or major arc. Then this is the radius. So perimeter is the distance around, so it's going to give us 2 radii plus the length of the arc. Now we know the length of the arc has a relation with the angle theta and the radius. So that is it. Theta over 360 times 2 pi r units. The area is given by this. Area is theta over 360 times pi r square. If we want to find the area of composite shapes like this, we can also do that. We know this is made up of a square or a rectangular shape and a semicircle. So the perimeter is given by AB plus BC plus this arc CD plus AD as a perimeter, and we know that this is an arc. So we can use the formula that we just talked about, theta over 360 times 2 pi r. This time the angle created by the semicircle is 180 degrees. So we sub in 180 degrees. We are going to get 1 over 2 times 2 pi r. That will give us pi r. We can find the area of this composite shape as the area of ABCD plus the area of the semicircle. The area of the shaded region over here is given by the area of ABCD minus area of semicircle. Now watch this very carefully. We have still finding the perimeter of this figure, but this time this is not a semicircle. It is just an arc. In other words, the d here is not a diameter, it's just a chord. In that case, to find the perimeter, we need to know the value of d. So d is given by the formula 2r sine theta over 2. Then also, that is the length of the chord. We are going to use this length of the chord formula to determine our radius. That is what we are going to use to determine the perimeter. So the perimeter is given by this, but the length, which is L, is found using this over here. So we depend on the d to find the radius or the theta. Information will be given to us. Then we continue to find the length over here. Let's take our very first example from WASSCE May June 2013. A segment of a circle is cut off from a rectangular board as shown in the diagram. If the radius of the circle is 1/2 times the length of the chord, calculate correct to 2 decimal places the perimeter of the remaining portion. So this is the remaining portion over here. This is not a semicircle but rather a segment. So this length is not a diameter. So whatever we find here is the length of the chord. Now we know from here to here is 22, and we can base on that to find the difference over here. So let's call this length d. So let this be d. We can find the value of d by this. So it will be 22 minus 8, because 5 plus 3 will be 8, which is 14 centimeters. Now we know the relation between the radius and the length of the chord. The relation is that the radius is equal to 3/2 times the length of the chord. 1/2 is the same as 3/2, and this will give us 21 centimeters. Now we know the radius and we know the length of the chord, but we know the formula for finding the length of the chord has the radius and theta in it. So we can base on that to find the angle theta, which will help us determine the length of this arc. So we know d is equal to 2r sine theta over 2. So we sub in the values for d and r to obtain this. Simplify further. Now we make theta the subject by taking sine inverse of both sides. Then theta is going to be 2 times this, and this will evaluate to 38.9424 degrees. Then we can use the length of the arc formula now. So which is theta over 360 times 2 pi r. So substituting all these values will give us 14.279 centimeters. So our perimeter now is equal to this: 22 plus 12 plus 3 plus 14.279 plus 5, and this will give us 68.28 centimeter correct to 2 decimal places. A trapezium PQRS is such that PQ is parallel to RS and the perpendicular from P to RS is 40 centimeters. If PQ is equal to 20 centimeters, SP is 50 centimeters, and SR is 16 centimeters, calculate correct to two significant figures, the area of the trapezium and angle QRS. So this diagram is not drawn for us, so look at how we are going to do it. We're told that PQ is parallel to RS, so let's do that. So this is PQ and this is RS. They are parallel. Then we can now join them. So this is our trapezium. Then the further information is that perpendicular from P, so this is P to RS, is 40 centimeters. So perpendicular to this is 40 centimeters. So this is how our diagram is going to look like. Now we are supposed to calculate the area of the trapezium. So these are the dimensions. or the measurement. We know the area is given by half times sum of parallel sides times the vertical height. So we just substitute the values. Then this will give us 1600 centimeters squared. Then the B part is asking us to find angle QRS. So we call this length X. We have to know any two of the sides of this triangle over here. So now we know only one, so we need to determine this length over here. We can never say that this is equal to this, because they didn't say that it is an isosceles trapezium. So we need to determine this. Now from this triangle we can find X. So we know X, we know that 50 squared equal X squared plus 40 squared. That is from the Pythagoras theorem. Then we determine the value of X to be equal to 30 centimeters. Now this is 30, but from here to here is 60, and we know that from here to here is 20. So 20 plus 30 will be 50. So we can determine Y now to be equal to 10 centimeters. Now we can use the tangent ratio to find this angle over here. So the angle over here, which is QRS, is given by tan QRS is equal to 40 over 10. That's opposite over adjacent. So this will give us the tan inverse of 4, and that will be equal to 76 degrees to 2 decimal places. A sector of a circle with radius 21 centimeters has an area of 280 centimeters squared. Calculate correct to 1 decimal place the perimeter of the sector. So we know that the area of a sector is given by theta over 360 degrees times pi r squared. And now they are asking us to use it to find the perimeter of the sector. So we know that the area is 280, so 280 is equal to the substitution that we make over here. The radius is 21. Then we don't know theta, but we know the pi to be 22 over 7. Now we make theta the subject to obtain 800 over 11 degrees. Next, we find the perimeter of the sector. We know perimeter is equal to 2 radii plus theta over 360 times 2 pi r. So we sub in the values. We know the theta to be 800 over 11. So this will give us this. Now we simplify this to obtain something like this. 68.7 centimeters to 1 decimal place. Angle properties of parallel lines. If two parallel lines are intersected by a transversal, this is called transversal, then these angles are formed. Corresponding angles or F angles, alternate or Z angles, vertical opposite angles or X angles, then co-interior or C angles. Now corresponding angles are equal. So all these angles are corresponding. A corresponds to B, C corresponds to D, so they are all equal. H corresponds to F, G corresponds to E, so they are equal. The alternate angles are also equal. These are Z angles, so look for a Z shape. So this is a Z shape. This angle is equal to this angle. This angle is equal to this angle. Then this is alternate to this. So this angle is alternate to this also. Then we have X angles are equal. So these angles, A equal H, C equal G, B equal F, D equal E. These are the X angles. Then we have the co-interior angles or C angles. They are supplementary. So we can say this C plus D be equal to 180. C plus D equal 180. So A plus B will give us 180. Then also B plus C will give us 180. Then A plus D will give us 180. Now this is not a parallelogram because not all the sides are parallel. In the diagram, ACE is a triangle, ACE, CF is a straight line, so CF, then we have BD is parallel to AE, so BD is parallel to AE, and BC is equal to CG, so isosceles triangle. If angle BCG is 36 degrees, angle BF is I degrees, and angle GCD is J, and angle DEF is 2J, this angle. Find the values of I and J. So this is how we go about it. You know, this is I, so this is parallel to this, so this is a transversal, this is also a transversal, this is also a transversal. So we can see from here that this is equal to I. So if this is I by the isosceles triangle, this must also be I. Then the sum of angles in a triangle BCG should be equal to 180. Then we solve for I to obtain I to be equal to 72 degrees. Now we use triangle ACE to determine the value of J. So we know that the sum of all these angles will also give us 180, but we know the value of I already, so we're solving to obtain this. Now 3J equals 72 degrees, therefore J to be equal to 24 degrees.